Hey guys, it's me. I just wanted to go over, we started doing the activities for Chapter 6 in AP Statistics this week, and I wanted to kind of go over some of the activities together with you because we did have quite a few people who were absent, and for those of you who missed a day or two, I thought this might help get you back on track a little bit quicker. Um, so instead of doing a class survey, I just kind of filled this probability model in just to save time. Okay. And the first thing, and these again are the worksheets from AP Stats Medic, which is just some of the activities that we have that just kind of bring in everything that we've done. So is this a valid probability model? Absolutely this is. The probabilities, what makes a valid probability model? Let's talk about this. Well, the probabilities that are in the model are between 0 and 1, all right? And the sum of the probabilities is 1. So that makes it valid, okay? Now, it's telling us, it's asking, then it says, is 5.7167 a possible value? Now, these are individuals. And so the answer is no, because we're talking about, this is a discrete variable. Okay, a discrete variable has whole numbers for values, 1, 2, 3, 4. You can't have 0.5 of a person. You can't have somebody enrolled in 2.3 classes. So things like that. That's the difference between a discrete and a continuous variable, so no. And it says to make a histogram of the display of the information on the horizontal axis and then describe its shape. Okay, so instead of, I tried to do some in the calculator and it was just kind of a disaster. So instead of doing that, let's just go ahead and use our own little brains to create a histogram. Now, there are anything between 1 and 6 children. So I have 1, 2, 3, 4, 5, and 6, right? And then the maximum number of people who had a certain number of children was 7. So this went all the way up to 7. So that's 1, 2, 3, 4, 5, 6, and 7. So remember, histogram is a great way of telling you frequency. So that's what we have to look at here. So there was one, for those that had one child in their family, we had 2 people that had 1 child. We had 6 people who had 2 children, I'm sorry, in their family. And then we had 7 people who had 3. Now remember, in a histogram, everything touches. There's no gaps or anything. It's not a bar graph, okay? And then 4, we had 5. So I'm going to do that. And 5, we had 4. So I go down a little bit. And 6, we have 2. Okay. So it's not perfect. But let's talk about the shape of this. Okay, so it's a little bit skewed to the right. And there's a single peak at 3. So what we're going to have to do is do verbal translations of what we have here, okay? So it says describe in words what px is greater than or equal to 3 is, and then find what p of x is. So the probability that a random, okay, so what is that? That's the probability that, let's write this down. The probability that a randomly selected student has 3 or more children in their family is. Now, if we look up at our table, we have 7 that have 3, 5, 4, and 2, so we add them all together. So 9, 16, 17, so that's 18 out of 26. All right. All right, describe in words what the probability of x is greater than 3, and then find the probability of x is greater than 3. So that is the probability that a randomly selected student has more than 3 children in their family. And that probability is 5 plus 4 plus 2, so that's 9, 10, 11, so that's 11 out of 26. So, and then it's going to ask us to find the average of the x values. Well, the x values are 1, 2, 3, 4, 5, and 6. So I just do 1 plus 2 plus 3 plus 4 plus 5 plus 6. I add those all together and divide by 6, and I get 3.5. And then it says, does this value tell you the average number of children and families of students in this class? If yes, explain. If no, explain why not. Well, no, because it's not a weighted average. All right. Okay. So like 6 shouldn't count as much as 3 does, right? So let's try to, so what we're going to do is take the expected value or the mean expected value. This is the whole idea of what the actual mean expected value is for probability. Now remember that formula is, here's your mean, it's the sum of each x value times its associated probability, and then you add them all up. So what I get is 1 times 2 out of 26 plus 2 times 6 out of 26 plus 3 times 7 out of 26 plus 4 times 5 out of 26. Oops. And plus 5 times 4 out of 26. And then plus 6 times 2 out of 26, right? So it's basically a weighted average, right? And that gave me approximately 3.346. Okay, so when I did that, remember, it's like if you have in the grade book, like your quizzes or your tests are worth 80%, but your quizzes are worth 20%. So your tests have a bigger impact, okay? Because it has a larger weight. And here, 3 should have a bigger impact. So it should be closer to 3 than 3.5. Okay? So hopefully that makes a little bit of sense. So let's go to the next page. I want to at least work on 6.1. And then we'll go to 6.2 if I have time to do another video. Okay? So here's the basic notes from this section, okay? A discrete random variable takes a fixed set of possible values with gaps in between. Continuous, it can take any value within that variable. and then you have your histogram, which is the probability, and it's really the frequency and the values, and here's your mean expected value. Okay, so let's do an example that relates to this. If you want to, go ahead and pause the video and try to answer some of these questions by yourself. All right, Indiana University Bloomington posts the grade distributions for its course online. Suppose we chose a student at random from a recent semester of its university's business statistics course. The student's grade on a 4-point scale, with A being is equal to 4, is a random variable with a probability distribution as follows. Okay, so the first thing we had to do was figure out what this one is. And this is, remember, this is an A, a B, a C, a D, and an F. Of course, you guys are all going to be there, right? So who has a C? So how many people, what's the probability of somebody getting a C? So write the event using probability notation, then find its probability. So the probability of X equals 2. Again, this is a discrete random variable because you can't, well, I guess you could get a 2.5, but let's just, for the sake of this, let's just do that. Okay. So I took all one and subtracted all these given values and came up with this last one, which is 0.138. So what is the probability in words that X is greater than or equal to 3? What does that mean? So let's talk about that. Sorry guys, I'm moving things around. Okay, so what does that mean? So what is a 3? A 3 is it's a B. So the probability that a randomly chosen individual gets a B or better in the class. Okay, so that is equal to 0.819. Now, how did I come up with that? I just messed that up. Sorry, guys. 0.819. I added the probability of getting a B, which is 0.362, plus the probability of getting an A, which is 0.457, and I get 0.819. Okay, so let's take a look at the probability distribution. Remember that our probability distribution, we're going to create a histogram for it. It's going to go from like 0.1 to like 0.5. It's going to be kind of strange, so let's talk about it. So here, we're going to do the probability of 0.1, 0.2, 0.3. I'll move this a little bit. 0.4 and 0.5. And then again, 0 is the value. So we've got 0, 1. That's a little too far, sorry. 1, 2, 3, and 4. So there's a very low probability, less than 0.1, of somebody getting an F in the course, which is great. All right. And then to get a D, again, is less than 0.1, so that's also good, but a little bit more. So that's good. And sorry, my scale is kind of screwed up here. Ugh. Anyways, you get my drift. And then for 2, we got 0.138, so it's a little over 0.1. And 3, there was lots of B's, which is great. It's 36%, so it's almost 40%. And then look at that, almost 50% got an A, which is awesome. So let's talk about that. This is obviously skewed left with a peak at 4, right? So let's calculate and interpret the expected value. So that is, again, you multiply the number times the probability. Yes, you multiply 0 times this, which just gives you 0. So 1 times 0.032, 2 times 0.138, 3 times 0.362, and 4 times 0.457. Okay, and that gives me 3.222. So the way I would explain that is that if many students were chosen at random, the average grade is about 3.222. Okay? So, all right, so that's going over day 1 of 3.1. I'm going to keep going over 3.1, section 3.1, and then I'll probably put in a different one for 3.2. Okay, so again, for the sake of time, what I did in class was I filled in this thing, without surveying the class and doing the whole thing. So, this is all about, like, what is your wage for a day? So students could have $1, $5, $7, $10, $15, or $25 an hour. And I just assigned different numbers to them, saying that we had a class of 22. I'm going to say 5 out of the 22 chose to got $1 an hour. 2 out of them, the 22, got $5. Let's say 10 got 7. 3 got $10 an hour. And I didn't have any that had $15 an hour. And then I had 2 that had $25 an hour, which is really nice. Okay. So let's figure out what the expected value of X is, and let's interpret that. So again, if we're to do that, remember, it's the sum of each X value times the assigned probability value. Okay, so the way I would do that is 1 times 5 out of 22 plus 5 times 2 out of 22 plus 7 times 10 out of 22, and then plus 10 times 3 out of 22, 15 plus 0 out of 22 times 0 out of 22, which is still 0, plus 25 times 2 out of 22. Okay, so we get approximately 7.5. All right, and then to interpret that is if we draw many wages at random, the average wage would be about 7.5. Okay, now, so what we're going to do is we're going to calculate the standard deviation and the variance for this. But what I want you to do is pay close attention, because this is going to be a weighted distance from the mean because of these values, and we're dealing with probability. So for the standard deviation, remember our formula is the sum of the difference between the X value and the mean squared times the probability that matches up with that value. So remember that our mean is 7.5. So what we're going to do is we're going to do that value minus the mean, right? And then we're going to square it. And then we're going to multiply it times the appropriate probability. So remember, the appropriate probability for 1 is 5 out of 22. For 5, 2 out of 22. So these are the PIs, right? 7 is 10 out of 22. 10 is 3 out of 22. 15 is 0 out of 22. And 25 is 2 out of 22. Okay, so what I want you to do is pause the video, and we're going to go through this step by step. I want you to take each value of x and subtract the mean from it, which is 7.5. So your first number is 1 minus 7.5, so that's going to give me negative 6.5, right? And then what I'm going to do is square that value. Remember, this will always end up being positive because you're squaring it. 42.25. And then I multiply it times this probability to get this number here. And that's 960. Okay, so do me a favor and pause the video and see if you can come up with those. And we can go from each point. So go ahead and pause the video. Okay, so what I'm going to do is I'm going to do 5 minus 6.5, and I get negative 1.5, or I'm sorry, 2.5, hello. And then 10 is negative 0.5, or 7 is, I'm sorry, or 7 minus 7.5, yes. And then I get 2.5, 7.5, and 17.5. And then I just go and I square all these values. I get 6.25. Remember, they become positive no matter what because we're squaring them. A negative times a negative is a positive, and a positive times a positive is a positive. Okay, and then I get 306.25. And then I'm going to multiply this number by this probability. So 6.25 times 2 out of 22 is 0.568. Same thing, 0.25 times 10 out of 22 is 0.114. 0.852, this one's easy, 0, and 27.8, right? Then I take all these numbers and add them together, and I get 38.934. This right here is your variance, not your standard deviation. I'm sorry. And then to figure out the standard deviation, I take the square root of the variance. So I take the square root of this number, and I get approximately 6.24. So now we have to interpret, now we have to interpret the standard deviation in words, okay, and see what that means, okay? So the wages typically vary by $6.24 from the mean of 7.5. Now, what I did here, guys, I skipped number 5 and 6 in class because I didn't want to spend too much time on uniform distribution. So forgive me, and we're just going to skip that. So what we're going to do here is basically do the exact same thing that we just did, but redo it in a different way. It's kind of crazy. So we have to calculate the standard deviation and go from there. So remember that some basic things that we want to remember is that the standard deviation of a discrete probability distribution is the square root of the sum of the difference of each value minus the mean squared times its appropriate probability. Remember, if we just square that number, that's the variance. Okay? Now, if we're doing this under for a continuous random variable, for continuous random variables, we're going to find the area under the curve. So we can do uniform distribution, but again, I don't want to deal with it today. So I take the mean and I have a normal curve with a mean and a given mean and standard deviation. And I would calculate the z-score, which is x minus the mean divided by the standard deviation, and then use table A, which is the same table that we were using. Or you would use your calculator with the normal CDF command. Okay, now what I'm going to do is I'm going to walk you guys through this and show you how you would do this through table A, but then I'm also going to show you how you would do it with your calculator. Okay, so we're going to do all the drawings and everything, because if you're doing a short answer question that relates to this, you absolutely have to do all the drawings. Okay, so the heights of young women can be modeled by a normal distribution with a mean of 64 inches and a standard deviation of 2.7 inches. Suppose we choose young women at random and let y equal her height. What type of variable is this, discrete or continuous? Now this is continuous because all heights are possible. Somebody could be 5'4.5", right? So it's continuous. Okay, the standard deviation is 2.7. So when we have a standard deviation of 2.7, what is the interpretation of that? Now this is a good thing that you guys need to be able to tell me. What does the standard deviation mean in words relating in the context of this problem? Okay, so in words, the heights of women typically vary by 2.7 inches from the mean height. Of 64 inches. Okay, so the next thing we have to do is find the probability that the height is less than or equal to 63 inches, and we need to interpret this value. So what we would do on a normal curve, again, remember you always have to draw your normal curve, okay? So you have a normal curve with a mean of 64 and a standard deviation of 2.7, all right? So remember, right here is going to be your mean of 64. They're asking you what's the probability that that value is 63 or less. So like say this is 63 and we want this whole area under the curve. So what we would do is first calculate the z-score. So that is the x value, which is 70. Oh, I'm sorry. 63. I'm sorry. So what is let's write out that formula for the z-score. It's the x value minus the mean divided by the standard deviation. I'm sorry. So that is 63 minus the mean of 64 divided by the standard deviation of 2.7. And that's going to give me a z-score of negative 0.37. Now, if I were to look this up on the, and that makes sense, right? Because this is below the mean. So when the value is below the mean, it's going to have a negative z-score. If it's at the mean, it has a z-score of 0. And if it's above the mean, it's a positive z-score. So if I went to table A and looked up that z-score of negative 0.37, I would get a value of 0.3557, okay? And so I would say there is a probability of 0.3557 that a randomly selected female has a height that is less than or equal to 63 inches. Okay, now I want to show you how I would do this on the calculator. Okay, so hopefully this works. Okay. Okay, I'm just going to take you through it, I guess. That doesn't show up very well, does it? All right. So I would press second vars and go under option 2, which is normal CDF. And my lower bound would stay the same, which is negative 1e to the 99, which is just a really low negative number. Your upper bound would be 63. Your mean would be 64. And your standard deviation is 2.7. Enter that into your calculator and you're going to get the same amount. Okay, so now we have to find a value. Let's interpret the value where it's in between these two values right here. So let's draw the normal curve. Remember, you can't do this without drawing the normal curve. So you draw your normal curve, right? You have your mean at 64, right? And we want to see it's between 68 and 70. So let's say that this is 68 and this is 70. And pretend, guys, that we really can't, that, again, as accurate as you can make it, but do whatever you can do. Like if you're like me, I can't draw a normal curve to save my life. So make sure you do that and indicate this. And so we're going to find the z-score for 68 and we're going to find the z-score for 70. So the first thing I'm going to do is find the z-score for 70. So I do 70 minus 64 divided by 2.7 and I get 2.22. All right. If I look this up on table A, this z-score, I would get an area of 0.9868, right? That represents the area from this point all the way down. Well, I don't want this whole area. I just want this area. So I have to take away this area right here. So I do that by calculating the z-score for 68. And that gives me 1.48. Now when I look up this area in table A, I get 0.9306. So I take the difference of these two. I'm taking this large area and I'm taking away this because I need this area. Okay? And I get 0.0562. If you were doing this on your calculator, this would be your lower bound and this would be your upper bound. Okay? I'll probably do a whole nother thing, but also if you look at the normal distribution worksheet video, it's exactly the same of what we're doing. So let's interpret this. This says there is a 0.0562 probability that a randomly selected female is between 68 and 70 inches tall. Okay, so that is all of 6.1. I will take you through some of 6.2 as well, and we'll go from there. All right, so hopefully this will get you through the first section. Please review your notes that I gave you, and we'll go from there. Talk to you later.